Hello again, welcome to the 9th video on electrical energy, power and energy usage. So all electrical appliances convert electrical energy into different forms. Okay, so a heater converts it to heat, a sound system converts it to sound, things like that. Now every electrical appliance is given a power rating, and that power rating tells us how quickly the appliance converts energy. Now remember, energy in physics, we measure energy in joules. Power is measured in watts. W-A-T-T with a capital W as the unit, not to be confused with the capital W we use for work. So the unit of power is the watt. And what 1 watt is, try and say that, what 1 watt is 1 watt means that 1 joule of energy is converted in 1 second. So 1 watt equals 1 joule per second. So a kilowatt, which is a unit you'll start hearing more about, is 1,000 watts, which is equal to 1,000 joules per second. Okay, so let's have a look at a typical light globe, the old school type, which are now being replaced by lower energy types. Now this is running on 230 volts because I stole it from an English book. Remember, Australia uses 240 volts, but it's a 60 watt globe, a globe you might use for a reading lamp or a room that you don't want too bright. And when it's connected to that voltage power supply, it's converting 60 joules of energy to light and heat every second, and its power rating is 60 watts. So at 60 watts it converts 60 joules of energy every second. Okay, some other typical power ratings. An iron uses a fair amount of energy, so it's got a power rating of 500 watts. A television, 650 watts. A hairdryer uses a lot of energy. That's probably why your parents are always telling you not to use the hairdryer so much. 1250 watts. And your bar heater, and often these heaters have switches on them, and the switches tell you how many watts you're using, whether you use 1 element or 2 elements, depends on how much. But again, heating uses a lot of energy, therefore adds to your phone bill, your electricity bill, sorry. So what's the relationship between power, voltage and current? Well, it's related to P equals VI. And on your information sheet you're given that, where power is in watts, capital W for the units, voltage we've used before, and current we've used before. So if we know the voltage and current, we can work out the power. So what about the electrical energy used? Well, the energy consumed by this appliance depends on the rate of energy use, or the power rating, and the time that it's being operated. So to work out the power rating, well, that's the power rating. This would be the energy being used divided by the time, and so that's the power in watts, and time is in seconds. And sometimes it's written like this, it's on your information sheet, where this is delta E, the change in energy, and that's equivalent to the work done. Now we have this formula on your information sheet because it doesn't just relate to electrical energy, it relates to a whole lot of other energies that we're going to do later on. So this represents work done, not the W there. And by moving these around and recognizing that P equals VI, we can say that energy equals VI times T, and because energy is equal to work done, we can say the work is equal to VIT as well. Now these two don't occur on your information sheet, but you're given all the other equations that go to make that one up. Okay, so these are all your power equations that you will find on your information sheet. Notice here you've got power equals VI, and then you've got a rearrangement and a substitution, because we know that V equals IR, and so we can substitute in IR for V, and then we get this. So P equals I squared on times by R. P also equals V squared on R. So depending on which two you know, you can work out the third. And we've got these two that we've already just mentioned. So it gets a bit confusing with all these equations, but if you've been following the ways I've been setting things out and you highlight what you're actually given in the question, and then you go looking for the equation to solve for what you have to find out, you can avoid a lot of the confusion. So let's look at an example. We're at 230 volts and it's drawing a current of 10.5 amps. And so what's its power? P equals VI. Just put the numbers in and you get 2,415 or 2.4 kilowatts. So another example is a 3-bar electric heater. It's turned on, current of 12.5 amps goes through it. The potential difference, so it's running at 230 volts. Calculate the power of the electric heater, and so V times I gives you 2,875 watts. They've approximated it up to 3 kilowatts. To calculate the total energy, you could use E equals P times T, substituting in VI here for P, or just going straight in and using the equation. Now they want to do it for 5 minutes. Now our standard unit for time is seconds, so here we go the power times by the minutes, and we've got to convert the minutes into seconds, so we times it by 60, and so this would be what's that, 862,500 joules, or approximately 900 kilojoules. Okay, so there's an example. Let's do another example. How much energy is consumed by a hairdryer that draws 14 amps of current from a 240 volt supply, which is what we have in Australia, for 12 minutes? Express your answer in joules and megajoules. So what are we given? We're given I, V and T. Okay, so let's start doing some writing. So that means we can, first of all, there's a number of ways you can do this. You can go P equals VI, because that's what we're given, and so we can work out the power rating, which is 240 times by 14. That will give us 3,360. What are the units for power? Watts. Now, you might also have recognized, if you were paying attention earlier, that we could use the equation E equals V times I times T. Okay, and effectively this would equal, we just put the values in, 240 is our volts, times by the current, which is 14, times by our time, which is 12 minutes, but we need to convert minutes to seconds, so we need to times it by 60, and that will give us our answer. Now conversely, if we're doing it this way, we should recognize that P equals delta E, the change in energy over time, or we could have used the equation work over time. In either case, we would rearrange it, so let's rearrange it to be E equals PT. Okay, and you might recognize that this is effectively the P that's equal to P. So here we've got the same equation that we have up here. Let's get back into this. Alright, and so if we put our numbers in that we worked out before, so 3,360 times by 12 minutes converted into seconds, we get our answer as 241,920. Luckily I did all that working before. It's on a sheet in front of me. So that's how many joules we have. Now we could rewrite that as, now of course there's a decimal place there, and we jump at 1, 2, 3, 4, 5, 6. So we could write it as 2.42 times by 10 to the 6 joules. Okay, so there's our answer in joules and also in scientific notation. But we could also write it in megajoules, recognizing that mega means 10 to the 6, so we just replace that. So that is 2.42 megajoules. Okay, so hopefully we followed all that. So you could do it very quickly here with the answer just there, or you could do it in a number of steps. Your choice. Oops, I just rubbed all that out. Okay, let's move on when you're ready. And so you're going to get a handout. There's our answer to that question, which is on the handout, and then you go have a go at all these questions, and by the end of it hopefully you're able to do the electrical energy type questions. And in the next video we're going to learn about paying for electrical energy. See ya.